Another important aspect of regression analysis is hypothesis testing, and I would like to start with some general comments. So when we run a regression, when we estimate regression coefficients, we would like to know whether our finding is compatible with some stated hypothesis or not, whether it meets the stated hypothesis or not. And the stated hypothesis is known as the null hypothesis, and it is always denoted by H0. So this is the first hypothesis, and then we take this hypothesis and we test it against the alternative hypothesis, which is denoted by H1. So as you can see, when we do hypothesis testing, there are always two hypotheses, null and alternative, and we test one against another. There are three types of hypothesis testing tests. Hypothesis tests, so two-tailed test, positive one-tailed test, and negative one-tailed test. If you look at the null hypothesis of each of these tests, you will see that it is exactly the same. So in my case, I've chosen the example of beta 2 being equal to 0, but it can be any other coefficient, and it can be set equal to any other value, 1, 2, 3, 4, and so on and so forth. But the difference between these tests is in its alternative hypothesis. So if we look at the two-tailed test, we can see that we will always have the non-equality sign. So beta 2, let's say, or beta 1 is not equal to some value. So this is when we have a two-tailed test. If we have the following signs, that beta 2 is higher than some value or beta 1 is higher than some value, then we have a positive one-tailed test. And if we have some coefficient being lower than some value, then we have negative one-tailed test, like in this case. There are two approaches which allow us to decide whether we should reject or whether we should not reject the null hypothesis. The first method, confidence interval, the one that I discussed in the previous video, and the new method, I believe it will be new for some of you, is the test of significance. So let's go through this test one by one. So to use the confidence interval approach, first of all, obviously we need to construct a confidence interval. I showed you in the previous video how to do that. Here is the formula. So this is how we construct a confidence interval for some estimated coefficient. After we've constructed the confidence interval, we need to see whether the hypothetical beta 2 under the null hypothesis, like in my case, if the value of 0, right, this is the hypothetical value that I've chosen for the null hypothesis, falls within the confidence interval. If it does fall within the confidence interval, then we do not reject the null hypothesis. However, if it is outside of the confidence interval, right, lower than its lower bound, higher than its higher bound, then we reject the null hypothesis. So once again, in my previous example, I've chosen the value of 0, so this is the value against which I check my estimated coefficient. And if this value of 0 falls within the confidence interval, so it lies between the lower and the upper bounds, then we do not reject the null hypothesis that the coefficient is equal to 0. However, if the value of 0 is, let's say, somewhere on the left or on the right side of the confidence interval, then we can reject the null hypothesis, and consequently we will accept the alternative hypothesis that beta 2 is not equal to 0. And the second approach is the test of significance approach. To use this test, first of all, we need to calculate something called t-statistic. Here is the formula. So beta 2 with the head, this is the estimated coefficient, right? The one we get from the regression results. Beta 2, this is the hypothesized numerical value. So if we check for the statistical significance of the estimated coefficient, then we set beta 2 equal to 0. So if we go back to my example, right, I've chosen this hypothesized value of 0, so I would substitute it right here into the equation instead of this beta 2. So this will be beta 2 with the head minus 0. And then we divide everything by the estimated standard error, which we don't need to calculate ourselves because the software will do this for us. So after we've got the t-statistic, the estimated t-statistic, now we can proceed to the result interpretation. And once again, I have repeated three types of tests: two tail, right tail, and left tail test. And here is the decision rule that you can follow in the future. So the null hypothesis, as you can see, is the same for all the tests, that the estimated value of beta 2 is equal to the hypothesized value, for example 0. And the alternative hypothesis in case of a two-tailed test, that is not equal to 0, that it is higher, and that it is lower than the hypothesized value. And let's see, so we reject the null hypothesis and consequently accept the alternative hypothesis if, in case of the two-tailed test, if the absolute value of the estimated t-statistic, right, the one that we get from this equation, is higher than the critical t-statistic. In case of the right-tailed test, we reject the null hypothesis and accept the alternative hypothesis when the estimated t-statistic is higher than the critical t-statistic. And in case of the left-tailed test, we reject the null hypothesis and accept the alternative hypothesis when the estimated t-statistic is lower than the negative value of the critical t-statistic. And I think that's now most of you are wondering how to get the critical t-statistic, right? This T alpha df. And here is a quick explanation. So alpha, as always, this is the significance level that we ourselves need to choose. Alpha over 2, this is the significance level divided by 2. So if we take 5% and divide it by 2, we get 2.5%. And df, this is the degrees of freedom. And degrees of freedom is always equal to the difference between n and k. So the difference between number of observations and the number of parameters. N is also known as the sample size. K, number of parameters, so the number of betas. So to get the critical t-statistic, we need to know the significance level, and we also need to know the degrees of freedom. After we have this information, we just go straight to the table and we'll look for the appropriate value of the critical t-statistic. We will practice this during the workshop, so for now you don't need to worry, but I think that some of you might still remember how to do that from our classes of statistics.